Okay, today is Thursday, the, what is it? Thank you, 19th, and we're taping the lesson on completing section 3.3 and starting 3.4. I'm hoping that I can, but possibly not, since we're going to be doing a worksheet. I will place the worksheet online for the ones that are absent. Please do not help them. They have the same criteria you do. Okay? Is that clear? Because I know some of you have instant answers. I was worried about some of you. I wondered what went on. It's biology, right? Y'all are way on the other side of campus? No. Okay. All right. So before we get started here, let's review our rules. Okay, before we get started. Okay. Derivative rules have to be known because we're going to have an exam in class. You have to know them by heart. There is no cheat sheet involved in taking a Chapter 3 exam. So we talked about our derivative rules. And we started with the dx of a constant. What is a derivative of a constant? Thank you. Then we said the power rule. D dx of x to the n is? That's it. Awesome. 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 We multiply the exponent times whatever's in front of the x and then reduce the exponent value by 1. And as much of the distributive as the difference quotient we've done, that should be understood, because every time we did one, it reduced the degree by 1, right? All right. So then we did, what did we do after that? The product rule, I think. On this guy, we had to do in relationship to one term and consider the other one a constant, and then do the other one and do the first term as a constant, or whichever way you wanted to do this. So the elegance of it said it was u ev dx plus v dx. But it doesn't matter which one you do first. But we understand it is an addition, and one of the terms is included as part of that product. U as a second one, plus V as a term. It has to solidify in your brain. I don't care which way you do them, so long you only do one at a time, right? One at a time. Because I have old habits and they're hard to quit. Then we had a very important one, dx of e to the x. What is this guy? E to have dx of e to the u, then I would have e to the u dx, because we have to then consider the exponent as a term with numbers. So we did a few in class, yes? Okay, everybody? Right, and I just reviewed the quotient rule. And the quotient rule was listed up here. That's where I started today. We're going to finish with those and see what else I have in store on this lesson. So this is find the derivative of the function, and we have a rational function. So we're going to use the quotient derivative. So, and they have y. I can write it as dy over dx. I can write it if I'm looking for a slope, or I can do it as y prime, right? Or I can convert it to a function, but to convert it to a function, I would have to do an additional step. Bless you. So I'm going to use y prime. Is that okay with everybody? So I'm going to have the 2x minus 7 times the derivative of 5x plus 8. Does everybody agree? Minus, and I'm going to have the 5x plus 8 times derivative of the bottom, which is 2. Does everybody agree? And we're going to do the bottom squared. So we're going to clean it up just a tad. I'm going to distribute 5 into that, so you got to watch me because you know I get so carried away with the process and not the math. So this would be 10x and a negative 16. Right. Oops, sorry. I do get crazy with my numbers. Thinking of the next step is what it is. So I'm going to clean it up again. 10x minus 10x, because that's what I have, is what? Well, 0, right? And then negative 5 with a negative 16 is, okay, 51. My hearing aids on, but sometimes I hear you all have soft voices. Okay, is everybody comfortable with that? Can I do any more? Except make it correct. Thank you so much. I appreciate you. Okay, we have another one. Is that okay? Is everybody comfortable? Everybody good? I'll leave it up there. I do. Can I do that now?
It's asking you if you have to square the calculator.
I did.
Not like right, or just leave it square.
Oh, never, never do. That's what I do. Yes, we get carrots. That's more important than if I had a quadratic that was listed. But I appreciate that very much. I do appreciate it. Okay, awesome. Excellent questions. On this one, the only difference is that we have a square. And on both the numerator and denominator, but we can't do anything like cancel or do anything with it. So we're going to apply the quotient rule again. Is everybody ready? You'll have the paper. And I'm going to do y prime again. I have, and this is 16x. Oh, it's just nasty, isn't it? Sorry. Two x. All right. So we took the derivative of the top times the bottom, minus the derivative of the bottom times the top, and we're dividing by the square of the denominator. And now we're going to clean it up. Does everybody agree with that portion? Yes? Okay. I'll move on. I'm going to distribute 16x. Oh my gosh. I'm going to distribute the 2x, and I'm going to do it in a step because I have the 2x at the back and I could miss a sign. So I'm going to have 16x cubed and 10 x's. right. I'm going to clean it up again. Now remember, you can take any shortcut you want because you have a calculator at hand and you're not likely to make mistakes like your instructor. So you are free to go fast. All right. So again, we notice that these guys are gone. And then I have 16x minus 10x is a positive. Yes. Okay, class. Questions on that? Pretty cool? Right. Now we're doing one with a second as well as a first derivative. And of course, it looks ugly, but we can do it. Yes? Yes. We're going to stay calm and we're going to get this done. Let me have some space here. All right. I'm going to again use y prime, and it's a quotient rule. And I'm going to have 6x squared. Derivative of the top times the bottom minus, and we're going to have the 2x cubed plus 5 times 1 all over x squared. And we're going to clean it up a little bit. All right. I'll clean it up again by combining like terms, and I should have a 4x cubed minus that 5 over x squared. How are we doing? All right. Everybody good? So we're going to do a y double prime, a y double prime. Another second derivative. Okay. All right. So this is 1/2 of that question. Okay. And what we're looking at is the changes in what is happening, because the denominator for sure is going to be x to the fourth, right? Because we're squaring it again. So we're seeing that this is making the output a lot smaller for whatever x value we're doing. And second derivatives are usually acceleration, but this is a y equals, so I don't know what this would be. I really don't. So, okay. So we're going to do the x squared, and we're taking the derivative of the first term. Of course, the numbers are big. Minus the first term times derivative over x squared squared. All right. Again, you can take any shortcut in your math that you feel confident in. Is that clear? You can take any shortcut you want. I'm trying not to make a mistake for you. Of course, I'm showing every step for anyone that needs it. A power and a power you multiply. So I'm going to clean it up. When I do 12 minus 8, I should get 4, yeah? All right, there is a step here we can take. what would that be? Yeah, we would factor out an x and reduce the denominator by 1. And that is part of that algebra component that we always speak of, saying, think smartly, you know? Okay, so I'm going to pull out on the side here. So then my y double prime is going to be again, you're doing things so that the easier to decide what your x value is and do the math more efficiently, whether you have a calculator or not, or a program that does it for you, which is the case in most of your engineering and science studies. Yes. Oh, I thought you had your hand up. All right. Questions? Now, this guy, I may or may not have given you enough room on the page, and I'm sorry about that, but I might not have. Normal line to the curve. I've mentioned this, but haven't really gone into detail on what this is. A normal is a perpendicular to a tangent line. A perpendicular to a tangent line. So we've got some kind of line going, and we're doing a perpendicular against that. We use this normal to gauge pressure in your eyeball. That is that. We use it when you're doing, when you see those guys with the little yellow thing and they're looking in there, that is a normal. We don't use it for speeding. What we use for speeding is cosine. Okay, so that's a different story. I'm just letting you know because that's also a ray onto something. There is some kind of visual application, but the eyeball is the best. The eyeball is the best. You're talking a tangent line here, and then they throw a light all the way to your optic nerve and see what kind of pressure your eyeball holds. Is everybody comfortable with that? Where does a normal exist? It also exists when you do matrices. You of a matrix to figure out the force within that the connection of the 2 or 3 or 5 functions, and it has to do with I think it's like a demand. This, right? I have to look that up again because I might be telling you wrong. I teach that, it just didn't come to mind. All right, so a normal is a perpendicular to what? Line. So you know, because you're going to draw a line and you don't even need the perpendicular slope. Okay, so how do I get slope for the tangent line? Take a derivative. That's all I want to hear. I ain't saying crazy functions now. We're going to have to take a derivative to find the slope value at the given point of the x value, and then we're going to do the perpendicular of it. How many know what that is? Perpendicular slope. So mathematically, it would be said it's the what? Opposite sign reciprocal. Opposite sign reciprocal. So if I take the opposite sign reciprocal, reciprocal means we what? Flip. And you have to remember every whole number is a fraction over 1. Basic mathematics tells us that it is an identity factor for division is 1. And you would never give me an answer of 5 over 1 unless it's a ratio or a gambling scenario on odds. That's when you would give me a 5 over 1. Is that clear? At this level, I would be very upset if that's what you use. Is that clear? Okay. The context of what answers you give me are determining your ability to reason. Does everybody understand that? Okay? Because all of y'all are going to be making more than I make talking to students. So there you go. All right? Are we good? Okay. So here we go. So we know what a normal is. That means the slope of the first curve times the slope of the second, or perpendicular, is going to be -1. And we write it like this. Or any form of it. One of them has to be negative. You start with a positive and get a negative. You can start with a negative and get a positive for the perpendicular, and then flip of that action. And that gives us normal. Okay, that's critical. And you run across this on, if anybody took the AP test for calculus, that was on there. They always ask you for the normal. See if you know your stuff. I don't know where else it appears other than real world application. But anyway, but I remember on the AP test, that's what they have. Okay, here we go. So I first have to get slope for tangent, line, the point 2, 1. All right. So I have an x to the third, y equals, negative 4x plus 1. I'm going to take the derivative. And this time I'm going to, you know what, I'm going to say, because it is a slope, put dy dx. All right. So I need the slope, and x is 2. Thank you. So this is 12 minus 4. It looks like a positive 8. What do you think? Math? Now we need the perpendicular slope. So that would be a what? Who said the negative? I thought it was a sweet voice. Okay, it's a negative, opposite sign, reciprocal, 8. So now we're going to construct the normal line. Now, I think in our homework, they asked for the tangent one and the normal, okay? But I'm just going to the normal. Is that all right with everyone? But in your homework, it'll say tangent, y equals. If somebody in here told me they forgot to put the y equals in the exam. So make sure you understand that it is a function, a complete function. So I have my point. I have my slope. And you work this one the way you were taught in your high school. And I'm okay with that. This is going to be 2 eighths, and 2 eighths reduces to. Thank you. So I'm going to have 1/8 x plus 5/4. And The use of fractions. Now, this one comes out nicely as a decimal. I don't know, and I promise I don't know, if on the homework it'll accept the decimal. I am not sure. I know it doesn't like it as a slope. So, but it might take the decimal for the C. Okay? Is everybody comfortable with that? Questions on that? Questions? All right. So the next one is the smallest slope. The smallest slope. So what is the smallest slope? 0. No slope, right? I would think. I don't know. I think so. All right. So what is the smallest slope? Well, we have the derivative from the top. Hopefully we did that one correctly, and I think we did. So now what we want is 0. Sorry, I have an itchy. And because we have a square, we have 2 areas where this function has a hump. And is it a plus or minus of that x value? And we're done. At what point? Oh, we're not done. I have to drop it in. But I'm not going to drop it in. Because I don't have my, yeah, I do. I do. Sorry. I do have it up. I just didn't want to take time. There we go. We're going to put in our function. All right, so I have my function. I'm going to go to second table and put in, let's go put in the positive. This is going to be approximations. Because I got a square root of 3. Yuck. -2. -2.079. And you'll notice it's irrational. Okay, because we have a square root of 3. Well, the negative of it, the positive. And again, these are approximations, and that'll say so. And I'm going to do, what did I do up front? 3 decimals. I'm going to do 3 decimals. There we are. Sorry about that. Okay. Then it says the tangent line has a specific slope. And this one's important because this one wants a slope of 8. And we're finding the x value in order to have the value of the function at that point. Is everybody comfortable with that? So on this one, we're still using and we're going to put in 8 here. I'm going to add 4. I'm going to divide by 3. and take the square root. Because it's a square, it's going to be a what? A plus or minus 2. Is everybody comfortable with that? So again, we have a cubic. So the cubic is flying, right? Flies up, goes down, and goes back up. Because it's in standard form, it's from negative infinity to positive infinity as the range. So, all right. So now what we need our function. Oh, such a cube. I know you see it. What was the original was +1. I hope I put. Yep, I did. I'm making sure. So I'm going to go second calc value, and I'm going to enter 2 and -2, and I'll get values of 1. So at 8, and they want find the equation of the tangent lines. So they want 2 of them. And is everybody good? Everybody comfortable with my math? Okay, thank you. I forgot to ask. I apologize. All right, so I have both of them. Of course, we always want to use our tool. Let me see if I put anything else on there. No. Okay, so we're going to use our tool. Okay, we're going to graph it. And there they are. And these guys are parallel lines. The idea of parallel lines is same slope of the function, and it's running tandem at 2 distinct points. Very comfortable. Questions? All good? Okay, this finishes section 3.3. We're going to take this little in-class activity. It's not a quiz. Are you? All right. Which I guess sounds like a quiz. Sorry. Not on purpose. It does sound like that. But you're using your notes. Okay. Did sound that way.